Okay, good afternoon. It is the top of the hour, 12 Central, at least down here in Alabama. I would like to welcome everybody to the Tree Fund webinar series. It is wonderful to have everybody back on. We have a fantastic webinar for you today. Tree Fund, I think, does one of the best webinars in the industry. I would like to first welcome you on behalf of the Alabama Cooperative Extension System. My name is Bo Broadbeck. I'm the Extension Specialist here for Auburn University, and it is our pleasure to host this webinar series for Tree Fund. I will be serving today as a co-moderator, but the lead moderator in the person who will give us an introduction to Tree Fund is Jim Urban. So Jim, I would like to turn the virtual floor over to you to give us a Tree Fund update and introduce our speaker today. Thank you, everybody.
Okay, well, welcome everybody. I'm Jim Urban, Tree Fund trustee, and have been a long supporter of the Tree Fund, and really pleased that you all are here. So the Tree Fund basically provides grants for research, scholarships for aspiring tree professionals, and support for arboricultural education, such as these webinars and other things that we do. All of the research that has been completed is on our research archives, which you can get to through the treefund.org site, and also abstracts for projects that we've funded but have not yet been completed are also found on this site. The next Tree Fund webinar we're having is measuring multi-stem trees on October 13th, and that will be the work of Laura Roman and Yasha Magarik. These webinars are presented as a free service from the Tree Fund, but during the corona pandemic, we're experiencing a dramatic reduction in donations. And we're asking you to consider a special donation to help keep the Tree Fund financially healthy. So during the webinar, if you can go to treefund.org, and on that first page, click Donate Now. And even a small $25 donation from everybody on this webinar would raise over $25,000 to help with the efforts of Tree Fund. For the landscape architects, we are offering LACES CEUs. To get your LACES certificate, you must go to a test question box. And at the end of this webinar, we will have the link to that chat, link on the chat box will come up. And you need to, I think you have to get an 80% pass rate or 75% pass rate for the 10-question test. And you have 10 days to complete the test in order to get your CEUs for this event. So we can move into the presentation. Today is Soil Management for Urban Trees, Part 2, Actions. Part 1 went through the various parts of soil assessment and different things that you need to know when you're looking at soil. Part 2 is what do you do with that information, and how does it affect what you can do at the site. Our presenter is Bryant Scharenbroch from the University of Wisconsin at Stevens Point. He's also affiliated with Morton Arboretum in Chicago. It's actually Lisle, Illinois, just outside of Chicago. If you've never been there, it's a fabulous place to visit, and they've got some very interesting soil things going on. So Bryant, I'm going to turn it over to you. I will stop my screen sharing, and you're in control.
Bryant, real quick, I was going to remind everybody, this webinar is being recorded and will be available on the Tree Fund web page probably sometime tomorrow. And if you have questions for Bryant, please place them in the Q&A box at the bottom of your screen, and Jim and I will bring those to Bryant's attention at the end of the presentation today. Thank you.
Okay. Bo, can you give me a thumbs up? Can you see my screen and hear me?
Yeah.
You sound great.
Terrific. Well, hello everyone, and thank you for tuning in. Thank you to the Tree Fund for inviting me back to talk about soil management for urban trees. Today I'll be talking about some actions that we might take in order to correct some typical urban soil problems. Let's see. So some learning objectives for today's discussion. We want to talk about how we can manage compacted soils for urban trees. Then I want to talk a little bit about conditions that are too wet and also conditions that are often too dry for urban trees. And then we'll finish up with talking about managing for fertility for urban trees. The information that I'll be talking about, much of it is covered in our Soil Management for Urban Trees BMP, Best Management Practices Manual, that's available through the International Society of Arboriculture. So if you're interested in learning a little bit more about some of the things that I talk about today, I encourage you to pick up this publication. This publication is currently being revised, and we hope to have a new edition of it out in the next month or so. Right. So soil management for urban trees covers these four aspects. Covers aiming, assessing, acting, and analyzing, or the 4 A's. So when we aim, we're setting a goal. What is the goal of the soil management? When we're assessing, we're out there looking at the soils, trying to figure out exactly what the problem is. We covered this assessment process in detail in the first webinar. Actions are what I'm going to discuss today, and these are the things that we can specifically do in response to those problems we've identified in the assessment step. And then the last step of this process is to analyze. Did the actions work? So that involves some reassessment. If they did, great. We want to record that and keep that information for future management. If not, well, then we may have to do this process of resetting our goals, performing some more assessment, figuring out some different actions, and then reanalyzing. So today we'll talk specifically about the action steps. I'm going to ask you some questions throughout the presentation, and this will be the first question. Question is, what are the most challenging urban soil problems for the trees you manage? And I'm asking this question because I'm interested in hearing your response, of course. These are some of the things I'll be talking about today. So getting a little background on your thoughts on this would be great. I'll let a few more responses to roll in, and then okay, Bo, I think we can go ahead and record the. All right, so the poll responses to this question, 33% of the respondents said compaction, 11% too much or too little water. Nutrient limitation was only about 2%, none of the above 1%, and all of the above about 54%. So over half of you thought that these three problems, compaction, too much, too little water, or nutrient limitation, are the problems that you often see. Well, that's great, because that's some of the stuff that we're going to be talking about today. All right, so the actions. So I chose to focus just on these 3 specific actions because there's a lot of things that we're doing in urban soils. These are the things that I'm commonly asked about and I commonly see as pretty unique, difficult, ubiquitous challenges for urban trees growing in urban soil environments. So we'll cover each of these in some detail. So this first one, compaction. In part 1 of the webinar series, we talked about assessment. We covered some things about why urban soils are so dense. We also discussed some of the problems associated with compacted urban soils. And I'm not going to recap all of those things right now, but I am going to focus specifically on, okay, we have a compacted soil. It's quite dense. It's problematic. Now, what can we do with this compacted urban soil? What can we do with the compacted urban soil? What are the BMPs, the best management practices that we might take as an urban tree manager, arborist, urban forester, landscape architect, etc., to deal with this compacted urban soil? So right species, right site, prevention and protection, tillage, and organic amendments. These are the BMPs that I would suggest for dealing with urban soil compaction. And I'll say a few things about each of these BMPs. Starting with right species for the right site. Here I have another poll question. So if you can put that up, poll, while I introduce and talk a little bit. So right tree, right site, I think is always going to be our #1 BMP for any of these issues. The soil that you can see on this slide on the right is a very compacted urban soil. It was actually intentionally compacted in one of our research plots. The dense layer is that layer starting at about 20 centimeters. This was compacted with heavy machinery. This is a silty clay loam texture. It was compacted to about a bulk density of about 1.8 at the beginning of the experiment. You can see some really excellent platy structure right above that layer, showing us the water's not getting through there and it's aligning those soil particles in those plates. This is a very difficult soil. It's a highly compacted soil and right species, right site. And I'm curious what sort of responses we might get for what tree we might plant in this soil. And I realize that we're coming from all parts of the world here in this webinar, and some of you may not be familiar with these specific species, but that's okay. I'm just using them as a point of discussion. So go ahead and Bo, why don't you end the polling there? All right, so it looks like 76% of the respondents chose the hackberry, the Celtis occidentalis, and 24% chose the Fraxinus americana. Okay, so those results are kind of expected. Both of these species are quite heavily planted in urban environments, and they're heavily planted in urban environments because we know them to be tolerant of some stresses that we see in urban soils, like compaction. If I was choosing between these species, I would lean towards the hackberry, as most of our participants chose. And I would do that for one reason in particular, is that in the Midwest and other parts of the United States, and I suspect other parts of the world, we have emerald ash borer who are going through and they're really hitting our ash trees quite hard. Now, compaction is this kind of sneaky urban soil problem that it might not kill a tree right away, but it'll certainly start setting it up for this downward spiral syndrome, in which eventually this tree is going to be more predisposed to other things that might come in, like insects or diseases. So knowing that we have EAB in the area, emerald ash borer, I would really lean towards not putting an ash tree in a stressful situation. Compaction is also kind of tricky, that I think whatever species you put in a compacted site, depending on the degree of compaction, you might experience some problems. So I don't think there's a really yes/no answer to this. It's a sort of a gray area. All right, let's see, where did my slide advance go? So a few other things I'd say about right species, right site. You have to become familiar with what trees work in your compacted soils. That's really important. Okay. We know that many species are able to tolerate some level of compaction. We also know that this is often the species that can tolerate that in their natural environments. These might be species that are found in more wet soils. So soils associated with floodplains, for example. Okay, and we know that some of these species that can tolerate compaction are found in natural wet soils because they are able to deal with living in these anaerobic soils that have relatively low oxygen concentrations. Some of my favorite recommended tough trees for compacted soils in the Midwestern United States are shown here on this slide. And I like some of these species because they're not some of our overly planted species, I think, in the urban environment. Okay, and they've shown some level of tolerance to compaction. So I got ginkgo shown there, metasequoia, and there's a white oak there. That white oak happens to be from the Morton Arboretum. It's thought to be the oldest tree in the Chicago area. That particular tree is greater than 330 years old, from the Morton Arboretum. Okay, so BMP number 2. Also a very, very important BMP when we think about how to fix compaction problems. Prevention and protection. Compaction can occur in a matter of seconds. So we can destroy that soil structure just by a few passes through with some heavy equipment or even walking on it. But it might take years, decades, centuries for that soil to rebuild its soil structure and regain those pore spaces that are lost in compaction. So preventing it is really probably our best strategy towards dealing with urban soil compaction. Soils are most susceptible to compaction when they're wet. So it makes sense to stay off them when they are wet. When soil's anywhere near field capacity, we don't want to be walking on it. We don't want to be driving on it. We don't want to have construction activities associated in this tree rooting zone. In regards to protection, so we know that the soil is a very important location for the roots to grow, and we want to make that soil the highest quality. So during construction is a typical place where the soils might be compacted. And if we can provide some level of protection to keep this heavy equipment off these soils during the construction, that's great. So here's some orange fencing that was provided to some of these trees during a construction project. This was near the College of DuPage, actually on the campus of the College of DuPage. And it appears that, they protected the soil underneath the current drip line. And,
Hey, Bryant, you've inadvertently muted yourself.
all right, can you hear me again?
Yep, thanks.
Okay. So these tree protections around this particular site, I'd say they're quite inadequate. When we think about the tree at maturity and the extent of that drip line, we really should be managing for that. Because if we want to have large urban trees that are living to longevity and providing all these excellent benefits we know that they can provide, well, we also need to provide a large soil volume for those trees. And we really should be thinking about protecting all the way out to the area of the mature tree at drip line and even further if we can do that. I'd say that these trees are set up for some problems at some time in their life due to the compaction that has occurred in this potential root growing area. So another BMP in regards to compaction, tillage. So we use tillage as a management strategy to deal with soil compaction. The intent is to go ahead and break up a plow layer, break up a layer that's been dense, that's been compacted. And in urban spaces, which are often confined, or maybe we have existing tree root systems, some of these tillage implements, such as a subsoiler or a moldboard plow, which is commonly used in agriculture, may not be feasible. In urban environments, we often might be using some smaller, more agile pieces of equipment, such as a rototiller or that core aerator showing down there. And we might use these in urban landscapes with the intent of breaking up these compaction layers. Some specific tillage that we perform for urban trees include things like radial trenching, drilling, high pressure air tillage. Again, the intent of using these strategies is to break up these compacted layers. Radial trenching, the idea is that we want to trench in areas and not disturb, hopefully not go through major roots, allowing those roots then to grow into those soils in which we've amended or possibly removed that compacted layer. With drilling, we're hopefully recreating some uncompacted zones. And then high pressure air tillage, which I think is a pretty common arboriculture tool these days, to go through and use that high pressure air to stir up the soil, to break up any potential compacted layer. At the same time, we're able to get a better picture of the root system and have an idea of what sort of specific problems we might be encountering with that root system. So does tillage work well for affecting or remediating urban soil compaction? So these are some studies that have looked at tillage alone, some different types of tillage, surface tillage, so just tilling up that surface layer, trenching, so providing trenches to break up that compacted layer. Deep jetting is similar to that high pressure, only in this case we're using water instead of the high pressure air. And subsoiling is deep plowing. For the most part, these studies have found rather minimal, short-lived, mixed responses for the effect of these tillage strategies on removing compaction, or essentially trying to lower soil bulk density. And you might ask, well, why is that occurring? So when we go through and we till up a soil, what we're doing is we might indeed be breaking up that compacted layer, but at the same time, we're also breaking up all of those soil structural aggregates. And those soil structural aggregates are essential for providing our pore spaces, specifically our macropore spaces, in which air can be stored for tree roots. So the tillage not only breaks up the compacted layer, but it also works to destroy soil aggregates. Other strategies for dealing with compacted layers, folks have looked at using some sort of organic amendment. The idea being that we want to somehow preserve or enhance soil aggregation. We know that soil structure is essential for the macropore spaces. So by providing some sort of organic amendment, can we stimulate biological activity and help promote the development of soil structure? The pictures shown on this slide are from one of our research plots, the Morton Arboretum. On this research plot, we removed the topsoil, we compacted the subsoil, we planted 120 trees on this research plot, and then we applied some treatments. And some of the treatments were organic treatments, such as the compost, top dressing, and a wood chip mulch shown here. And then we wanted to know, were these treatments and others effective at reducing that soil bulk density, helping those trees to grow and thrive on this site? Here's our response data. After 5 years, we found that soil bulk density, which is shown on the y-axis there, was significantly reduced in our compost top dressing amendment and our wood chip mulch amendment, or mulch. The other treatments in this research plot were a nitrogen, phosphorus, potassium inorganic fertilizer, an aerated compost tea, a commercial biological product, which included microorganisms, and then we had a control. And we saw only a significant reduction in soil bulk density with those organic amendments and mulches, the compost and the wood chips. This occurred after 5 years. I'm in trouble getting my advancer. And why this occurred is because on those organic treated plots, that mulch, wood chip mulch, and that compost top dressing, we saw soil structure being formed. I'm holding aggregates in my hands here from that research plot. The aggregates on the right are massive structure. The aggregates on the left in this image are subangular blocky parting to granular soil structure. And we saw that granular subangular blocky structure being formed in that compost treatment and also that wood chip mulch treatment. And we think it was occurring because we were seeing the microbial population increase in its activity and biomass, and also we were seeing tree growth responses from these treatments. So it's the biological aggregation that was occurring in response to these treatments that were helping repair that soil structure, in turn reducing that soil bulk density. We found that in turn, that improvement in soil structure, overall soil quality, also translated into an improvement in tree health and growth. This shows tree biomass, and we found significantly greater tree biomass in our wood chip treatment compared to our null, our commercial biological product, and our compost tea. The inorganic fertilizer in the compost were intermediate in response. And we know that the increase in tree biomass due to some of our modeling was at least in part due to this improvement in soil bulk density. Some other things that were going on to help the tree biomass or improve the tree biomass on specifically the inorganic fertilizer in the compost related to fertility, and also some of the effects of water. So follow-up studies to that research that we're performing and also other folks are conducting are, can we include organic amendments with tillage? And the idea being, can we use tillage to break up these compacted layers and then incorporate organic matter into the soil to help stimulate that biological activity to create that soil structure? So in some instances, we might need to use tillage to break through some of these hard pans, but at the same time, can we still work to preserve or promote biological aggregation? The images on this slide are from another one of our research plots. This one happens to be in Bolingbrook, Illinois, and these are street tree landscapes, very compacted soils in which we used air tillage and an organic amendment incorporation with the air tillage afterwards to stimulate the biological activity. Here's a summary table of some of the folks and some of the findings that people have been finding with organic amendments and or tillage. And I'd say that we are finding that organic mulches and amendments have some promise in reducing soil bulk density and potentially dealing with soil compaction. And also, some folks have found that when we incorporate this organic material with tillage, we can also work to reduce soil bulk density. The paper we have in review currently is the Bolingbrook study. Susan Day and others have been looking at these organic amendments with subsoiling for a while as well too, finding some promising results. So I think the key here is that we can certainly address compaction. Right tree, right site is number one. Prevention and protection, also number one. And then some sort of organic amendment, mulch, or stimulation of the biological activity is really critical. Compaction is a pretty big issue and something that we've been doing research on for quite some time. If you're interested in learning a little bit more about soil compaction, I encourage you to check out another one of our Tree Fund webinars. This one was specifically on urban soil compaction. In addition, there's a fun little public service announcement that some students at University of Wisconsin-Stevens Point put together on compaction, also on the YouTube. Go ahead and click that if you're interested. All right, so the next problem I'm going to discuss is moisture. And specifically, I'm going to talk about soils that are too wet and what are some actions we can take to deal with that. Okay, so what can we do about soils that are too wet? Again, start with right species, right site. We can consider proper irrigation. In some instances, we might work to promote some drainage through infiltration and connectivity. We can divert surface water and we can drain subsurface water. So I'll talk just briefly about each one of these next. Start with another poll question. So, Bo, if you can pop that up for me. So here we have a soil that is very wet. This is an anaerobic soil. It's very gray in appearance. It's been saturated for quite some time. It actually has some really strong sulfur smell in it. Some gray redoxamorphic features. And on top of that, it's been mulched. And it's not wet because of compaction. It's actually wet because it has a relatively high water table. Okay? This is a situation in which we're not talking about a little bit of compaction here that's inhibiting the water. We're talking about a high water table. This is going to be a site that is always wet. And trying to drain it wouldn't make any sense because we have a high water table. So really, option number one then is putting the right species in this. Go ahead and end the poll, Bull, please. Okay, and it looks like 94% of folks said we should be planting the river birch here rather than the Austrian pine or the Pinus nigra. And I would certainly agree with that result. River birch, a floodplain species, one that is known to tolerate very wet conditions. Austrian pine, more of an upland plant. Okay, so when we're looking at a really wet site with a high water table, look for those plants that we typically see in these wet environments. These plants that we know that have hydrophytic properties, hydrophytes. All right. Many urban landscapes are intended to be wet. So here's a picture of a rain garden in Washington, D.C. Rain gardens are intended to accept stormwater, hold it, prevent runoff. Okay, so we know that this landscape is wet. So when we're planting this landscape and selecting species to put in it, it's just critically important that we select the right species. Here again, you can see we have another birch planted. Probably a good species for that particular site. At that same time, some urban landscapes, they're just going to be too wet, and we should consider, do we really need to put a tree in that landscape? So this is a picture from the Morton Arboretum. This is a very wet area. It's a stormwater retention pond adjacent to one of our green parking lots. Very high water table, lots of flooding, standing water all the time, and there's only a select number of species that are going to be able to do well on a site like this. And maybe not all sites are suitable for urban trees. BMP number 2 is we want to make sure that if we are irrigating, that we indeed should be irrigating and we're performing proper irrigation. Irrigation is often something that we're doing with urban trees, either to get them through the establishment period and sometimes even beyond that. Okay, this is an anaerobic soil from the University of Idaho campus. This anaerobic soil is very glade, extremely wet. It had an irrigation system, and it probably should not have been irrigated. It was a silt loam texture. It had a mulch layer, had a very high water holding capacity. And yet they were irrigating it, and the soil was so wet that trees were dying in the landscape. The simplest solution would have been to turn off the irrigation. In some instances, we can work to improve the infiltration, which is the water moving into the soil, and the conductivity or the water movement within the profile. And that all comes back to what I was talking about with compaction. Repairing the soil structure, moving from something like massive or platy structure to granular or blocky structure with some macropore spaces to allow that water to move through. And again, the best way to do that is going to be through trying to promote biological aggregation. And this isn't going to be something that I'd suggest doing in a high water table situation, but maybe in a minor compaction issue, that's what's causing the poor drainage. We can divert surface waters. So we can use things like berms and swales to redirect water. This is a picture from Three Bridges Park, which is found in Milwaukee, Wisconsin. And the topography you're seeing there was created in an attempt to mimic the drumlins that occur in this area. And the effect of creating these drumlins on this landscape was to create a variety of wet and dry landscapes. And in doing so, they're able to expand their plant palette. So they planted a number of bur oaks on the upland areas, and they had lots of hydrophytes down in the lowlands. So we can use topography and things like berming to redirect surface waters. In some instances, we might have some pretty severe problems with wetness in subsurface layers, and drainage might be required to address those. Okay, and drainage is effective and cheap at installation, but it's very expensive and very destructive to install afterwards. This picture shown here is from Millennium Park. And we were doing an inspection, figuring out why the trees were dying. This was a very anaerobic soil, and there was nowhere for the water to go. So the only solution really was to install some drainage there, which would be a very expensive, very destructive project. All right, urban soils are often too dry, and I'll talk next about how we might deal with some of that. What can we do about urban soils that are too dry? Right species, right site. Get more water into that soil. We can prevent the water from leaving soil with mulches, We might apply different things within the soil to hold on to more water, and prescription irrigation. Start with another question. So here's a very dry soil. This is a sandy soil near Stevens Point. Has a very low water holding capacity. And which species might you put in here? So we got Ginkgo biloba or Taxodium distichum, bald cypress or ginkgo. All right, go ahead and end it, Bo. It looks like 82% have selected the ginkgo. Okay, and I think that's the one I would go with as well too. That bald cypress, it's typically a species that we see in wetland environments. It actually has some morphological adaptations that allow it to live in wetland environments, like pneumatophores. The ginkgo is a pretty species that can tolerate a wide variety of conditions, including been known to tolerate some drought. Here's another picture illustrating right species, right site. This is from Phoenix in the United States. Very hot, very dry environment. And in this very hot, dry urban landscape, they planted mesquite, which is a tree that does well in the desert. It's known to tolerate these very hot, dry environments. So in this case, here's an example of the perfect tree for that particular hot, dry site. In a very dry situation, if we can do things to increase the water movement into the soil, that would be ideal. Here's a picture from a green parking lot at the Morton Arboretum. This green parking lot is constructed of permeable pavers and bioswales to direct the water into the vegetation. Those permeable surfaces allow water to infiltrate into the soil, and also we're directing the water here into those bioswales for the trees to take up that water. If we're dealing with a dry soil, well, whatever moisture we can get into that dry soil, it would make sense that we'd want to keep it in that dry soil. One of the most effective ways at keeping that moisture in that dry soil is to put a cover on it, some sort of mulch. What I've shown here is a wood chip mulch, but any sort of protective cover to prevent evaporation from the surface is a BMP that we'd use in a situation in which that soil would potentially be dry. Here's some data from that research project I mentioned a few slides ago. This shows the volumetric water content throughout one of our growing seasons that we monitored. Shows those same treatments, our control, our wood chip mulch, compost, the NPK fertilizer, compost tea, and a commercial biological product. At every sampling time, we saw significantly greater volumetric water content on those plots that were treated with that wood chip mulch. And it was one of the major reasons why we saw that increase in tree biomass to be greatest with that wood chip mulch. The wood chip mulch was not only stimulating biological aggregation, but it was also keeping moisture in that soil to provide for that increased tree growth. So it's very effective at keeping water in those dry soils. Are there things that we can put in the soil to increase its water holding capacity? And there are. These things can be organic amendments and they can be inorganic amendments. So what I've shown here is some data taken from a couple of studies. Some of the work that we've done looking at things like biochar, which is a charcoal-like substance, and biosolids, which are those particular composted sewage sludge. And we found that these sorts of amendments are very effective at increasing the plant available water, or the water that's available to plants. Okay, that water held between field capacity and permanent wilting point. In comparison, other amendments, inorganic type amendments like hydrogels and silicates also can work to increase plant available water. In comparison to some of the organic amendments that we've studied and others have studied, sometimes they might not be as effective. But these are both strategies that we can utilize to increase the water holding capacity or the plant available water in a dry situation. Prescription irrigation is the last BMP I'll talk about with dry situations. Okay, here we have a landscape with tree gator bags and sprinkler systems. And we can certainly irrigate urban landscapes. And we should in some instances, but I think we should do this in a prescription situation, meaning that we know that water's a valuable resource, a valuable and limited resource. We know that putting too much water on the landscape might result in some problems such as anaerobic conditions or even some environmental problems like leaching or runoff. So I think it'd be wise to take a prescription approach. In taking a prescription approach, we want to consider who needs the water and where that water is coming from. The soil, the groundwater, precipitation, irrigation. And we can just do a simple demand and supply. And I'll go through an example. So if we want to know the supply of soil or the supply of water from the soil, we can estimate this based on our soil texture classes. Okay, this is a commonly done thing in the field of Soil Science 101. Okay, we know that certain soil textures hold more plant available water. In this example, a sandy loam soil, 25 centimeters depth, we know that a sandy loam soil will hold approximately 12.5% water. That's the difference between field capacity and permanent wilting point shown on this graph. And that means for every 1 millimeter of soil, we'll have 0.125 millimeters of water being held in that soil. And if we know that we have a total of 250 millimeters of soil, in that 250 millimeters of soil, we have a plant available water of 31.25 millimeters. And that's our supply side. The other side of it is the demand. And we know some information about urban trees, how much water they demand. So here's just some information about bald cypress and ginkgo that I pulled from some literature. And if we put those supply and demands together, we can compute something like how many days will it be until that soil dries out and we want to turn on our irrigation system. So for that bald cypress, which has a 10 millimeter water per day demand, and we're talking about a supply of 31.25, we know that in approximately 3 days, we would be running out of water if we don't receive additional inputs from precipitation or groundwater. Then maybe we want to turn on that sprinkler system. In comparison, the ginkgo, which if we know that have a lower water demand, 5 millimeters per day, with that same water supply, we wouldn't have to turn on irrigation systems until we had about 6 days without incoming water. So, and these of course are estimates, but I think these estimates are much better than just blindly going out there and turning on our irrigation systems without any sort of insight into what the actual plants require. And we can certainly calibrate these estimates by looking at plant health responses in those landscapes, measuring soil moisture contents, okay? The point I want to get across is I think we can take some prescription irrigation approaches rather than just blindly irrigating landscapes that we think are dry. Okay, the last problem I'll talk about is fertility and how we can manage some infertile soils. Okay, there's two VMPs I'll talk about with fertility. Again, right species, right sites. You can see that showed up in each one of these. And then prescription fertilization. So here we have our last poll question. So we have a relatively infertile soil. These two soils are both from Boston area. One is a sand-based structural soil. One is a rock-based structural soil. Both of them have relatively low nutrient contents. They also have relatively low water holding capacities. Okay. What species might we put in either of these? What species might you plant in a soil like this? Your choices are red pine or basswood, linden tree, lime tree. Okay, well, why don't you go ahead and close her up. So 67% went with the red pine, 33% with the basswood. I suspect people choosing the basswood may have chosen it just because they think it might be a better urban tree, and it probably is for many other reasons. Okay. If we just want to consider fertility alone, I think red pine might be a better selection. Basswood or lime tree, if we look at the forest that it typically occurs in some of our richest forests. Okay, some of those forests that have very high concentrations of calcium and magnesium and some of our other bases. Compared to pine, we typically see in some of our more infertile forests. So prescription fertilization, we often are dealing with situations in which we think we might have a nutrient deficiency. In those situations, maybe the approach is to apply some nutrients, and we can apply these nutrients in a variety of forms. We might apply them in inorganic fertilizers or organic fertilizers, either bagged up, such as this milorganite, or maybe these organic fertilizers are coming out of the back of the truck, such as for compost. Okay, and I'll talk a bit about each of these. Again, I'd like to consider a supply and demand approach when we think about fertilization. Think about the supply of nutrients in the soil and fertilizer, and then how much is demanded by the plants and microbes. And I'll go through an example here. Okay, so let's talk about trying to compute the supply of nitrogen in a typical landscape, an urban tree lawn. And we can do this. Okay, so we first have to determine, if we want to know how much nitrogen a soil has, we need to figure out, first off, how much mass of soil we have. And we can figure the mass of soil by knowing the soil bulk density. Okay, so here I've given you a soil bulk density of 1.7 grams per cubic centimeter. We need to know the total volume of soil we're dealing with. So the area I'm talking about is 100 square meters, so a 10 meter by 10 meter. And the depth is 25 centimeters. Okay, and then we need to know how much nitrogen is present there. And we can get that from a laboratory result, or we could estimate that from organic matter content. Okay, and in this example, I've sent off a sample and got a laboratory test result. In that laboratory test result, I've gotten my total nitrogen content of 0.5%. Not all of that nitrogen is immediately available for uptake. Some of it is mineralized each year, and that becomes the immediately available for uptake. This nitrogen takes the form of things like nitrate and ammonium. Okay, so if we do this computation, the answer for our supply side is about 21.25 kilograms of available nitrogen in this space. Then if we look at the demand side, so we can use some of our assumptions from the ANSI standards, the American National Standards Institute, the A300 standards, that tell us that the demand might be between 1 to 3 kilograms of nitrogen per 100 square meters, or 2 to 6 pounds per 1,000 square feet of nitrogen. And if we look at this same situation, this demand for this tree growing in this 100 square meter, we could then assume that maybe the demand is between 1 and 3 kilograms of nitrogen. So for the example, we'll say 1 kilogram. And now let's put these numbers together and answer the question, is fertilization necessary? Okay, so assuming a tree demand of 1 kilogram of nitrogen per that area, what soil test levels would merit a nitrogen fertilization? Or what soil test levels would tell us that we're having a deficiency? The approach that I would take to do this is set up a ratio. So with our known soil, we know that we measured 0.5% total soil nitrogen, and that translated into 21.25 kilograms of available nitrogen. And the question is, what soil nitrogen amount that we would get from the lab would tell us that we're actually at 1 kilogram of available nitrogen? Okay, and we cross multiply this ratio, a total soil nitrogen test of 0.24% total nitrogen would tell us that we are at this threshold of 1 kilogram available nitrogen. Okay, so expanding upon this idea a little bit, let's say that we are in a situation in which the supply is not sufficient to meet the demand. What exactly do we do to address with that? And I'll go through an example with an inorganic fertilizer and then also an organic fertilizer. Okay, and we'll say that our deficiency is we want to apply 1 kilogram nitrogen per 100 square meters. And we want to do this with an inorganic fertilizer, a 3510 fertilizer, and we're going to use 50-pound bags. Okay, so we need 1 kilogram of nitrogen applied, and we have 30% kilograms of nitrogen in the fertilizer. This particular fertilizer, we've read from the bag, all of it is available. And that's not always the case, but for this example, we're dealing with all of available nitrogen type nitrogen. And each bag weighs 22.7 kilograms. Okay, 50 pounds. So the answer would be, we need to apply 0.15 bags of fertilizer, about 3 kilograms of fertilizer, 300 grams, about 6 pounds of that fertilizer to meet that deficiency. And we can also do that with an organic fertilizer. And this is the last example. I could do this with a wet compost that has a 1.5% total nitrogen measure, 10% total nitrogen available, and 40% water. To do this, I first need to figure out, step one is figure out how much water, how much total nitrogen, and how much available nitrogen is in that compost. You can see the ratio I've set up here. In step two then, I'm going to set up a ratio based on my known compost. My known compost has 0.009 kilograms of available nitrogen in 1 kilogram wet compost. And I want to apply 1 kilogram of available nitrogen. So how many kilograms of wet compost do I need to apply? Cross multiply. And I know that I need to apply approximately 1,000 kilograms of wet compost, which is about a cubic yard. Okay, so I can take that same approach with an organic fertilizer as well. All right, so those were some BMPs and some ideas for actions related to compaction, water, and fertility. Recognizing that there's many other problems that you might be dealing with urban soils, and I didn't address any of those today. Some other problems include pH, salts, etc. Also recognizing that this is just one step in the process for soil management for urban trees. It's a very important step, but we can't forget that we also need to be setting goals, assessing, and analyzing to see if our actions actually work. So with that, I thank you for your time. There's my email address there. Thank the Tree Fund again. And I think I'll turn it back over to Jim now. Is that correct?
Thank you very much, Bryant. I've been making a list of the primary questions that we've been seeing. One more little reminder here, if you appreciate this webinar, please consider going to treefund.org and making a donation to support the webinar program. And next slide. Hey, Bryant,
Yep.
Bryant, there we go. So for landscape architects, the reminder that you need to go to a link that Monica just put up in the chat box to take a 10-question test, and you have 10 days to complete the test. For ISA CEUs, I believe you just apply for it. You don't need to do anything special. Monique, if I misspoke there, I assume you'll chime in. So for ISA CEUs, you just apply during the normal way that you do things. So we are supposedly out of time, but Bryant and I can have time for questions. So I will turn the mic back over to you. One of the important questions I saw was for both compaction and water tolerance, overwatering and low fertility, those kinds of things. Where do you get the information on how a tree species, if you're looking for tree species, how it is tolerant of these conditions if you're trying to pick the right tree?
Yeah, Jim, that's a great question. So I think the question is just more generally is where do we get this information on right species, right site? And that's a really difficult one. You can certainly go to books like the Durr book or our extension agents. There's an abundance of information that out there that tells us that, this species A tolerates compaction, species B is a little bit more intolerant of it. And it's sometimes overwhelming, even just trying to figure out some species here when I want to talk about today. I think you can use those resources, but then you also have to pair that with what you see in the field. And for your landscapes in particular, you have to be somewhat familiar with what's going on the site, and then also the responses that you're observing. And that's why I think it's just so critical that we become better at assessing what's going on in the soils to understand that, hey, we're looking at a compaction problem here, and this is what this tree response is going to be when I have compaction in these landscapes I manage.
Yeah, I would agree with that. I feel like the professions that are dealing with trees, and I'm particularly speaking to my brothers and sisters that are landscape architects out there, our job is to understand the material we're working with. And while it may seem daunting, there are good sources for, Bryant mentioned Mike Durr's book on trees, the Manual of Woody Landscape Plants. And he always discusses soil conditions and tolerances, very good place to start. But we as professionals should learn this. And I know that landscape architects training in trees and soil conditions has not been as good as it should have been. It seems to be getting better, but it just takes work. And so we need to do that. One of the questions about wood chips that many people had in your experiment on wood chip mulch and wood chips as an amendment, can you define or talk to us about when you just put the wood chips on top of the soil versus actually tilling it in, and what difference, it was a little confusing in looking at your slides when you were tilling it in and when you were just putting it on the surface.
Sure. Yep. Yeah. So I didn't have time to go through all the details in those experiments. The wood chips, we always only apply wood chips as a mulch in any of the experiments I've conducted. So wood chips have always been a mulch amendment. It'd be a mulch, not an amendment. Some of those amendments that I showed you in the other experiment, specifically the Bolingbrook, in that case, we're applying a compost. Or in that particular one, that picture was showing was a biochar actually. So wood chips I always use in our experiments as a mulch, and then some sort of compost material. Those are my preferred amendment. And I do that because if we try to mimic nature and we go out and we dig a soil pit out in a forest, what you typically see is, woody material on the surface. And as you go down that soil profile, you're going to see different stages of decomposition. Okay, and that material is getting more and more decomposed as it makes its way into the A horizon, and then you don't even recognize it as organic material anymore. So I think it's just best to mimic what we see in nature. If I'm trying to provide a better environment for a tree, well, I think a forest is an ideal environment for a tree.
In many soil mix specifications, the question was, when you put organic matter, compost or wood chips, but let's just say compost, in a soil mix where the soil might be quite deep, 2-3 feet, the problem of that compost deep in the soil going anaerobic, and what is your recommendation on the amount of compost you should put in a soil mix that's intended to go very deep?
Again, I go right back to nature on that one. I look at the natural soil profile that I see in a forest environment, and that A horizon, that surface enriched horizon might have an organic matter content of 5, 6, 7%, but very quickly that organic matter drops off. And we don't see high concentrations of organic matter in subsoil horizons in forests. So when I'm applying organic materials, I'm applying them as surface amendments. I'm letting them work their way down into a profile to develop something that mimics a natural forest environment. So if I'm making a recommendation, it might be a 5% by volume compost amendment to the surface horizon, but I haven't done research on looking at subsoil amending with organic materials. And I just don't, that's not the direction that we've taken in our research, because we look towards nature to kind of inform us on what we've been doing. Now, other folks have looked at that. And if you want, you could.
Okay. There were a lot of questions about salt, which you had at the end. That we're not going to have time to do this, to talk about it. But I'd just like to say that there is a very good webinar on salt in the archives of Tree Fund that we did 6 months or so ago. And if you go and look at that webinar, which is a free webinar on the Tree Fund site, you'll probably get many of your salt questions answered. Let's see. The issue of calculating the amount of fertilizer that goes down, you outlined a fairly precise methodology. What would be wrong with just sending your soil sample off to a lab, which you already have to do to get the nitrogen, for example, and just asking them for their fertilizer recommendations?
Sure. So I think you're talking with an inorganic. There would be nothing wrong with that. Assuming that in that interpretation, they're also asking you what type of soil you have, and getting some information on those conditions. My experience with some of the labs and the interpretations that are out there is that there's not, relative to like agricultural settings, there's not as much urban landscape interpretation available. So we need to make sure that we're interpreting towards trees and the urban landscapes.
Yeah.
But if a lab's able to provide some of these things for you and do that, that's great.
Can you call the lab and I from personal experience, I agree that a lot of time you may get fertilizer recommendations for crops. We're not worried about crop yield here.
Yeah, we're not, the big difference between crops and trees, well, there's lots of differences, but crops are a perennial, trees are a perennial plant. Crops are taking, oftentimes the assumption is they're taking almost all that nitrogen up every year and you're resupplying it. Now there might be some residual nitrogen that carries over from year to year in a cropping system, but they're operating under the assumption that most of it's being depleted every year. Whereas a perennial system, you're not using up all your nitrogen. So it's a completely different beast.
Another question was, what do you do in soil if your potassium and your P and your K are too high? You get a very high reading. So you've got really the opposite problem.
Yep, sure. So if your phosphorus is too high, so one of the things I didn't cover, but I put in this slide set, we're often applying, I'm going back to this thing, we're often applying a fertilizer like an NPK. And as we're applying that nitrogen, we're also applying phosphorus. And if you have a soil that's high in phosphorus and you're applying an NPK fertilizer to meet the nitrogen demands, you very well could be over applying what is needed for phosphorus. So you need to use that initial assessment step to figure out, okay, what is the limiting nutrient, if at all there is a limiting nutrient on that site, and then you should be directing your prescription fertilization towards that particular element. So if you're in your assessment, your baseline sampling, you see that you don't have a nitrogen deficiency, you actually have a phosphorus deficiency, well, you can take that same approach towards prescription fertilization, you just tailor it towards phosphorus. Okay, and if anybody has any of those specific questions, I'm happy to talk with you individually, but I would need things like your soil test results, and then we can talk through how we do a calculation for you individually. And I'm happy to share these slides too with some of the math. I know that. Yep.
I think something to remember is this webinar is being recorded. It will be available on the Tree Fund website. So check probably by the end of tomorrow and you can rewatch it. I know there's a lot of information. Dr. Scharenbroch, you packed a lot of stuff in these slides. And so for those of you that want to go revisit those and watch them a little bit slower, absolutely go back and watch those, that recording.
And here's the information on phosphorus if you're interested. I put it in the back of this slide.
So you will be able to, for the LACES seniors, you'll be able to re-watch this, or if you came in late or had to leave early, you can re-watch it before you take the test. And you've got 10 days to take the test. So I think we said we were going to end about now. We're over, but that's fine. Both Bryant and myself are always available for questions and discussions. And my email is easily jimtree, that's JIMTREE @gmail.com. So jimtree123 @gmail.com.
And I just wanted to thank everybody. I saw a note from Monica that looks like Tree Fund raised $1,200. So thanks for your generous donations.
Thanks, guys.
Just a reminder, that'll help go towards future research like some of the one that's funded some of the work that Dr. Scharenbroch has done. So thank you.
Thank you.
Thank you.
So with that, I think we'll go ahead and close today's webinar. Thank you, everybody, for attending. Thank you, Dr. Scharenbroch. Thank you, Jim. Thank you, Monica, for helping us put all of this together and for sending out those fundraising reminders to everybody. So join us in a few weeks. We will have another Tree Fund webinar coming up a little later or mid next month. Looking at, gosh, I wasn't prepared. What's the topic, Monica?
It's the measuring of multi-stem trees.
Correct. And so look forward to seeing everybody there, and I will sign off. So thank you, everybody.
Thank you all.
Okay.